Hi, Steve here at the SJCUE Fab Lab, and we're going to be looking at the 8th grade math uh, STEM lesson, specifically the computer science part of that. So we're going to use a few great tools, well, a couple of them. One is MakeCode, and another is Desmos. And we're also going to take a little bit of time to think about and talk about the computer science standards. Let's get started. So, computer science has 5 different areas. Uh, we have computer systems, we have networks and the internet, we have uh, algorithms and programming, the coding that we often think of as being computer science, which is a part of computer science, but not all of computer science. We also have impacts of computing because we want the students to make tools and solutions to problems that benefit everyone. Uh, so we want them to think about how what they're creating affects other people. And lastly, we have data and analysis. So we're going to really be focusing on data and analysis in today's lesson. So just to review, the standards that this lesson will be looking at are 6.8 DA7, represent data in multiple ways. By the way, we're going to be using 2 tools that are going to help us work with data. One's going to be Desmos, which is a graphing calculator, and another is going to be Microsoft MakeCode. We're also going to look at 6.8 IC 23. So compare trade-offs associated with licenses for computational artifacts to balance the protection of the creator's rights and the ability of others to use and modify the artifacts. So students are going to be thinking about how we create cars, because cars nowadays are, well, they're kind of robots, right? They're machines. They're able to do complex tasks, namely drive us around, sometimes park for us, sometimes make sure that we don't bump into something. They're more than a car a generation ago. All right, so the impact, students are dealing with those impacts of computing standards. And lastly, 6.8 NI5, explain potential security threats and security measures to mitigate threats. So, so many of our devices are connected to the internet. What does it mean if your car is connected to the internet? Okay, so let's go ahead, get started looking at Microsoft MakeCode and Desmos. We're going to start with the graphing calculator. So uh, if you check out Desmos, uh, on its opening page, you'll see this. Um, I want to point out there are multiple tools there. The scientific calculator is great. We're not really going to focus on it today, but realize it's there. It's a handy calculator, and at a recent training, one of the teachers shared with me how useful it was that all the students had the same calculator when they used Desmos in the classroom. So that was a great point. Um, I'm going to click on graphing calculator. So here's our graphing calculator, and I'm just going to give you a couple of basic tips with Desmos. First off, you can use it in order to make a point. I mean, like a mathematical point. So I'm going to say 0, 0. Oh, hey, that is called the origin. So I'm going to say I want to add a label, and I'm going to say origin. All right, next, let's say I went with 5, 5, 3. All right, well, as I put in these pairs, it will graph for me. Awesome. Let's keep going. Okay, let's look at what else we can do. Hit return, and then say v equals 3. All right. What if I say that I have a point which is 2v? Well, now it's at 2, 3 because I defined v as 3, but I also have a slider. So I can move the point up and down. I could also, right now it goes between positive 10 and negative 10. I could change the range right here. Maybe I want it to go as low as negative 5, but as high as 20. So that now, when I move the slider, it changes where it might go. I can also have it to go on its own. And in that way, oh, there it's moving, I can create an animation. It's pretty cool. Now, that's going to come in handy because we're going to use it in order to make a model. All right, so right now we have this dot moving up and down on the screen. What we're looking at is the motion of cars, so we want it to go horizontal. Not too hard. I'm going to change what we've defined here. I'm going to say instead of V2, I'm going to make it well, let's make it V2. Let's see what happens. Oh, there we go. Now I have something that's moving along on the screen back and forth. I can change my animation. So instead of it going back and forth, it just goes forward once. So let's say that I want it, I'm gonna change it from V, which we tend to think of in physical science as the velocity. Let's go with T. Make this based on T or time. And let's say it starts at T equals 0. And then I want the position of this little dot to be 0, height 0, so on the ground. And we're also going to have it be, let's say it's moving at 2 times T. Or I could say it's V1, but I could define V1 as 2T. All right. I can also say that I have another velocity, V2, velocity of another car, but it's moving the opposite direction. But at 3T, 5 minus V2 at a height of 0. All right. Also, I'm going to make that a plus because I want it to go the opposite direction. Okay, let's try this out. Boom. Okay, the two went past each other. What I can do is I can change my ending time. Let's move back in time. Okay, they met right there at T equals 1. Great. So I'm going to say, you know what? I only want this to go as high as 1. I'm going to change the step to be 0.01. In other words, I want it to go just a little bit at a time. All right, let's try out our animation. Boom. Okay. We have 2 cars, one moving faster, one moving slower. It's a model. It's a model of a car. Students should go ahead, try out plotting points. They can also make a line by saying something like f of x equals 3x. Hey. And even cooler, let's say that instead of saying f of x equals 3x, let's say I have another variable called, well, you know what? Let's just say it's equal to mx plus b. So I've now made these sliders, and I can adjust everything. In this way, I can find a line of best fit. So students can plot different times or velocities, make a line of best fit. The students can try out different velocities with the cars, these dots in our model, change it, make it so it works a little bit more like what they notice in class. So I'm going to point out students are going to be recording how fast their cars move in class. They might have a little motorized car or a spring powered car that you let go of and it moves. But students are going to have their own cars. They're going to look at how those cars behave and they're going to get to modify a model that we're going to add into our website so that you're able to refer to it. But it would work pretty much like the one that we made together right now. Let's also take a look at MakeCode and how students can make a model in MakeCode. All right, here we are at MakeCode. We're going to choose MakeCode Arcade, which is going to be a lot of fun for the students to work with. I'm just going to go ahead and say New Project. I'm going to call this Cars. Now, MakeCode has sprites and a background. I'm going to choose both of those because I want a car and some place for the car to drive. So let's start with the background. I'm going to start Scene, set background image 2. I'm going to put that into On Start. Anything that I put into this On Start location or On Start function is going to run as soon as my program starts. I'm going to click, and rather than draw my own, which we could draw our own little scene for this, I'm just going to choose one that's already made. Here, I'm just going to go with the road. Oh, all right. Now, when my program runs, oh, hey, there it is. You can see it in the corner there. It's going to look like that when we run our program. Next thing, I need some cars to be in here. So I'm going to say, well, I'm going to make a sprite, and I want that to show up when the game begins. What do I want it to look like? Again, I'm going to click on this empty box. And I'm going to choose from the gallery. Students could draw their own, but I'm just going to choose one. Oh, it could be a snake or a tree. I just want a car. So we could have a plane. I'm just going to go with greenish blue car. All right. Again, since we said on start, we put in the on start function. Oh, there it is. It's shown up as soon as the game began. I'm going to click right here. Oh, we can see it a little bit better. I can also exit out of this by clicking here. All right. So I have a car. Good. I have a background. Let's put the car somewhere. So I'm going to go to sprites and say, I want to set the position here. I can put a number value in there, but I can also just kind of easily go, well, I want it about there at X is 8, Y is 57. Oh, there it is. And you know what? I'm gonna duplicate because I don't just want one car at one position. I want two cars at two different positions. So let me choose a different appearance. Scroll down a little bit more and go with this pinkish car. Okay. And I notice this one's called My Sprite. I'm going to choose a new name because it's a second car, like a second variable. So I'm going to call it car 2. While I'm at it, the first one I'm going to name car 1. Okay, so each thing that deals with it, I'm going to make sure has a logical name. So I've got car 1 and car 2. And where do I want car 2? I'm going to choose a spot. I want it to be at Y of 57 so that they're at the same height. All right, let's go ahead, click in the corner and see what it looks like. Okay, this looks like we want it to look. Now really all that we have left is to make it so they drive towards each other and stop. All right, well, that brings us to something called an event. And an event tells some code to to run when something occurs. So I'm going to click on controller. I'm going to say, you know what? When the A button is pressed, I want my car to move. So let's try it out. Now, one way I can deal with this is to just set a velocity. I think that's probably going to be the easiest way to go. So I'm going to say set car 1 velocity. Let's go with 15 pixels, 0, so 15 in the x direction, 0 in the y. I'm going to duplicate. Notice I right-clicked and say car 2, when that A button gets pressed, it's going to go the opposite. So I'm going to say negative. And making this kind of like our last model where the other car went faster, let's say about 25. Negative 25. All right. Let's see what happens. Does my model work? I'm going to click on the A button. All right, they're driving, and, well, they drive past each other. So that's a problem. But that problem existed in our first model. Let's fix it. I'm going to exit, and let's set up a rule. I'm going to say, every time the game updates, I want a condition. I want it to ask something. So I'm going to put a little bit of logic and say, if what? Okay, and just to point out logic, we have logic that we think of all the time. If it's sunny out, then I don't need to bring an umbrella. If it's Monday, then I go to work. There's a clause that can have that sets up a statement that has a true or false value, and then depending on whether or not it was true or false, I carry out an action. We're doing the same thing here with the program. So if what is true? Well, we could say if the x and y location, if the x location of car 1 is equal to the x location of car 2, then stop. That works. That's one way that we can do this. Let's look and see if we can do this any easier. Oh, hey, I can just ask if they overlap. So if car 1 overlaps with car 2, I can just say, well, this is over. It's my easiest choice. Now, students might choose some other cool stuff to happen. Game over. It's kind of boring. But again, I could also say something simpler like set velocity. In fact, we could do that right now. I'm going to get rid of the game over. Instead, what I'm going to say is, once the two are overlapping, I want the velocities to be 0. In other words, they stop moving. So 0, and here, 0. All right, let's try this out. All right, I'm going to click on A. Oh, it's driving, it's driving, it's driving. And they stop. All right, now that's a really simple model. We can have the students to change their model in order to be more like what they observe in the classroom. There's going to be a link to an example of this model on our website. There's also animation and a copy of the code. Feel free to rewind, look at the code again. There's really not that many blocks of code to this. Students can be really creative and come up with their own program. Now, I do want to point out that students have two other things that we're looking at. One of them is, well, software, right? The impacts of computing. If I were writing a program that determined how to stop these cars from crashing, and I made it open source. In other words, everyone has access to it. Does that make it more secure because then people can help me figure out what problems there might be, or less secure because now people can figure out what I'm going to do or what my car will do and maybe get around the precautions? Is it a problem for my company if I make that software open source and then other companies use it, and that stops me from making money so that I can make more cars? It's something for students to consider. Who knows? They might be starting their own tech company. Another thing that we're considering is networks and the internet. If I have like global positioning in my car helping me determine where it goes, do I want that sent out without it being encrypted? We would probably want that information encrypted. It could be a problem for your location to be out there all the time. So students can consider things like safety as far as network. They can think about things like copyright. Please go ahead, give kids a chance to practice this, to be creative. They might try out make code before doing this larger activity or this more directed activity. Just start out with coding something to say how they're feeling today. Eventually, they'll make their model and be able to explain what it is that they made. All right. Thanks so much for joining us. I hope you and your students have a fun time coding and working through the computer science and engineering and science in this lesson. Have fun.